hydrometer is an instrument used to measure the specific gravity or relative density of liquids. Specific gravity is defined as the ratio of the density of the liquid to the density of water. A hydrometer is usually made of glass and consists of a cylindrical stem and a bulb weighted with mercury or lead shot to make it float upright. The liquid to be tested is poured into a tall container, often a graduated cylinder, and the hydrometer is gently lowered into the liquid until it floats freely. The point at which the surface of the liquid touches the stem of the hydrometer is noted. Hydrometers usually contain a scale inside the stem so that the specific gravity can be read directly. A variety of scales exist and is used depending on the context. The experiment aims to determine the percentage of different grain sizes contained within the soil. The hydrometer method is used to determine the distribution of the finer particles. Specimen apparatus and supplies needed for the hydrometer analysis experiment. Beaker, 1000 ml graduated cylinder, hydrometer, mortar and pestle, oven, number 200 sieve, soil sample, thermometer, and distilled water. Use the mortar and pestle to crush the soil. Start sieving using the number 200 sieve and make sure the base pan has no holes. Achieve at least 50 to 100 grams of soil. Leave the sieved soil to the oven for at least 24 hours. After 24 hours, proceed to the hydrometer analysis experiment. Take the fine soil of at least 50 grams, place it into the beaker. Add 125 ml of dispersing agent or simply distilled water. Stir the mixture until the soil is thoroughly wet. Let the soil soak for at least 10 minutes. Use the gloves and elastic band to keep it intact. Transfer the mixed soil into the graduated cylinder and add the distilled water until the 1000 ml mark. Cover the open end of the cylinder with a stopper and secure it with the palm of your hand. Then turn the cylinder upside down and back upright for a period of 1 minute. The cylinder should be inverted approximately 30 times during the minute. Remove the stopper from the cylinder. Record the time and temperature. keep the thermometer in place, you can use your ID lace to keep it hanging. After an elapsed time of 1 minute and 40 seconds, very slowly, carefully insert the hydrometer for the first reading. Repeat the same process. Suspend the hydrometer slowly. Take the hydrometer reading after elapsed time of 1, 2, 4, 8, 16, 32 minutes, and to at least 24 hours. Once the experiment is done, make sure the apparatus are clean for the next experiments. One must dispose the soil properly and wash thoroughly with soap and water the materials used. Data and results. These are the data obtained in the hydrometer analysis experiment. Formulas and computations. Apply meniscus correction to the actual hydrometer reading. From Table 1, values of effective depth based on hydrometer and sedimentation cylinder of specific sizes. Obtain the effective hydrometer depth L in cm. For known specific gravity of soil, obtain the value of K from Table 2. Calculate the equivalent particle diameter by using the following formula. D is equal to K multiplied by the square root of L over T, where T is in minutes and D is given in millimeters. Determine the temperature correction Cp from Table 3. Determine the correction factor A from Table 4 using the specific gravity of the soil. Calculate corrected hydrometer reading as follows. RC is equal to RA minus 0 correction plus CP. Calculate percent finer as follows. P is equal to RC times A divided by the weight of the soil sample in grams times 100. Adjusted percent fines is equal to PA equals P times percent finer of 200 C over 100.
Having errors in this experiment is crucial to the results. One error can come from when the researchers were mixing the fine soil particles in the solution. Some soils stick to the spatula and the beaker, therefore reducing the amount of soil that can be measured. Human error is highly possible to happen since obtaining the reading on the hydrometer based on the meniscus is only human assumption. This increases the risk of the error while doing the experiment. Procedures should be strictly followed to minimize errors. The objective of this experiment is to determine the percentage of the different grain sizes contained within a soil. The group used the hydrometer method to determine the distribution of silt and clay in the soil sample. Hydrometer data readings were collected in specific time schedules. The readings of the hydrometer would continue until the reading reaches 0. It was expected that the settlement of the soil particles and the reading of the hydrometer to reach 0 at approximately 4 to 5 hours. However, after 8 hours, the reading was still above the 10 mark. It would probably take more time for the soil sample to settle, so the group decided to record the final reading at 5:38 p.m. instead of waiting for the hydrometer reading to reach the 0 mark.